I will be using a few slides, but there's no text on it, so you're going to have to listen to me. And so the slides are really an aid for me to help craft the story that I want to talk about. And the topic I want to touch on is how to increase spatial awareness, specifically from the point of view of challenging perceptions, and how the convergence of space and ICT is enabling that to happen. And I think where I want to start with is just continuing a bit of a theme that was started very early this morning about how innovation probably started on this continent and moved outwards. And what we've seen is that this innovation has picked up pace. And we're seeing all kinds of amazing stuff that's created. But my personal belief is that the best that we're going to achieve is still to come. And in order for us to be able to achieve this future, the sustainability of the environment, of the resources, is imperative. And so, for many of us that are involved in space science and technology, the Earthrise was a defining moment. It was when technology and space technology stopped becoming about exploration and technological superiority amongst nations and started becoming about understanding the planet. It was about looking back at the surface. It was about looking at us, at about this speck in the universe, and understanding a bit more of what was going on. So the thing about human beings, though, is we perceive the world not as it is, but as we are. And so if I were to ask you to picture Kilimanjaro, and for those of you that were actually there, you might have a different view, but for many of us, this is what would come to mind. And the question is this really the way it is? And the way we solve this perception problem is through measurements. And as Earth observation scientists and remote sensors, we understand this. And so we measure and we measure and we measure. So that's where this big data problem starts arriving. Because in order for us to understand what's going on, we're collecting huge amounts of information and data. And so it's the challenge about is how do we assess and process this to be able to change these perceptions. And I want to quickly take you to a small corner of the Earth and try and do that. So what's interesting is that in literally seconds, I could take you right there and immediately start challenging your perceptions about what's going on. And what we're seeing here is actually 30 years of data collected from a single satellite, the Landsat, that's been merged together with Google and NASA through their massive parallel processing machines that enables us to take a look at any place on the surface of the Earth and see what's going on. And you can see that Kilimanjaro actually changed quite dramatically around about 98, and that pristine glacial view that we have is probably not valid anymore. Now, this is an interesting application, but what's really interesting is that we're talking about 1.5 million scenes, close on to 200 terabytes of data that's been collected over 30 years, that's now rapidly and easily available, searchable, accessible, and anyone can literally start challenging perceptions. And that's the part that's interesting to us. Because what's undeniable now, by looking at things like this, is the effect that we're having on the planet. And that some of this change is perhaps even accelerating. But the crucial thing is, do we understand the consequences and the effects of this change? And that's really where space and ICT have started to come together to be able to enable us to start understanding these changes. But what's happening is with this, with all of this, I want to change slides. Now what's happening is that in order to be able to challenge these perceptions, we're starting to measure more. We're starting to collect more and more data. Satellites, there's more and more missions. There's more and more data. Their persistence is increasing. Their spectral range is increasing. Their spatial resolution is increasing. And over and above that, we have these decadal missions, these science missions that have been collecting data that are even more accessible. But over and above that, we have these in situ sensing, or the in situ sensing domain. And we've heard a few people talk about this. You know, you have almost 1 billion devices that are going to be out there collecting and measuring almost every perceivable thing that you can. And all of this data is starting to come in. And so the challenge that we're faced is dealing with this data deluge, as we call it. You know, you've got increasing variety and velocity of data. It's actually gone to exabytes. And so now in order to be able to challenge perceptions, it's about how do you deal with this? And that's really where the edge of research is. That what used to be a geographer's domain, you know, understanding the environment and satellites and the science around that, has started to become an ICT solution space. And that's the area of research that we're particularly interested in. It's how do you pursue the algorithms, the data processing, the information handling, and the delivery that can keep pace with all of the sensing that's going on. So, without a doubt, you know, remote sensing and in situ sensing became a pillar of the information society, and we understand that. And if we want to start thinking about the future, about, you know, a new brave world in which all of the sensing can start helping you and can start making sense, it's about how do you collect, how do you analyze, and how do you deal with all of this information and put it into a system that enables you to move forward. And that's where I think ICT technology is really going to come to the fore and unlock the socioeconomic benefits. And now we've heard the concept of socioeconomic benefits, but what do we actually mean by that? And so for me, I'm pretty sure most of you on your way here this morning probably used the navigation devices on your phones, looked at the traffic information flowing in to gauge what's the best way to come here and how long is it going to take you. And it's quite surprising how that just became part of our lives. You know, we stopped thinking about it and we just started using it. It saves us time, it saves us stress, we know how long it's going to take us to get from A to B, and it's actually changed our behavior. And that, for me, is, in essence, a socioeconomic change. And so if we were to think about a smart world, we've already started to see that. And one of the things that or a few of these applications I want to touch on a little bit, because it's the topic of research work that we've been going and working on. So if we think about the architecture that drives our research and the topics that are of interest to us, what we've been doing is taking traditional technologies, traditional solutions from signal processing, from machine learning, machine vision systems, middleware layers that enable these interconnected applications to talk to each other, and web provisioning. And we started to put all of this together into what was traditional remote sensing and information and geography type solutions, or geography type topics. And that's enabled us to propel these applications into a whole new domain, particularly into market aligned research and market aligned applications. What was important for us was that from the concepts of design-led innovation, we first focus on the user experience. How is it that people want to engage with the information? And we've taken that and we wrapped it around the main technology, which is around the analytics and the ICTs and the big processing and the parallel processing computers, as well as all of the data that's streaming in, and put these applications into the hands of people. Now, to think about some of the trends a little bit that enabled us to be able to do this. The first was this convergence between space and ICT. You know, what started off as perhaps a communication-led drive, we started seeing that the traditional processing techniques were started to being applied on this big Earth observation data that was collected from satellites. Broadband started to become more mainstream, and further there was this wave of information empowerment. You know, people started getting used to having a lot of information at their hands and using this for decision making. But more recently, there was this massive digitization, digitization of the environment, particularly through the sensors that were measuring them. There was miniaturization, wireless computing, and quite importantly, open standards and the technologies that were based on them that enabled interoperability. And once all of these things started coming together, we were able to create these really unique and interesting applications. And so the best way for me to explain or to talk through all of this ICT jargon and technology is to just use some very real examples. And I'll start with examples of solutions that were designed and built by our team here in the CSIR. So first off, these were fires that were at the Tokai forest in Cape Town in March of this year. destroyed an area of roughly 5,000 to 6,000 hectares. But interestingly, this was vastly different from the fires that broke out in exactly the same area about 10 to 12 years ago in about 2002, where 10 to 15,000 hectares of damage was experienced at the cost of around about 5 to 600 million rands. And one of the important differences that was around in this time was that at the control center, at the Disaster Management Center in Cape Town, they were running a solution that we designed and built called AphiS. AphiS sent out the first alerts to those fires at 2:14 a.m. on the 2nd of March 2015. Those alerts went into the cell phones or to the cell phones of the fire people that actually have to deal with this. That information was also available in the control center. Every day during the course of that week, we sent out what's called fire danger indexes. It's an indication of the risk of the fire spreading during the course of that day. And at the end of that week, the first burn scar map, the area of damage, was mapped out and provided to the people that need to deal with rehabilitation of this space. The second one that I want to talk about is a solution called CSIR. South Africa has close on to 1.5 million square kilometers of ocean territory. It's a vast, inhospitable area. But it's a critical economic resource for us. The potential about oil exploration, fishing, particularly for food. And close on to 4,000 vessels a day travel through our waters. And so the challenge that we face is how do we manage this entire area? How do we deal with all of these resources? And CSIR is an Earth observation-based solution that enables that to happen. And I don't want to talk too much about the system, and I rather want to talk about the most recent experiences using it. Now, 2 weeks ago, in the Mozambican Channel, sorry, the lighting is not really great, but there was an oil slick, or what's called a bilge dump, that the system automatically detected. That's 160 kilometers long. But not only were we able to detect that, we were also able to correlate using the transponder information from the vessel which was the offending vessel from all of those 4,000 vessels that were traveling through that waters, identified the vessel, which port did he leave, which port was he going to, and all of that information was then provided to the authorities on either side of the channel, the Madagascans and the Mozambicans, to be able to take this further. CSIR is also able to detect what's called dark targets, patterns of illegal fishing, vessels moving in and out of the economic exclusive zone in largely an automated fashion. And this starts to present or to provide eyes into areas that we never had before, and a much more efficient way of being able to manage your resources without needing to drive up the cost that it takes to do this. The last one that I want to talk about is a system called Azimuth. South Africa is endowed with many mineral resources. We heard this morning about the drive from government to try to improve our mineral extraction and to use this for greater economic benefit. Azimuth is able to monitor on a 24-day cycle all of the coal mining areas in the country and pick up millimeter to centimeter scale deformation as the coal is being extracted. Now, why is this important? That deformation is a collapse of the surface. And generally, the coal mining is undermining areas that are generally agriculture or where there may be other forms of infrastructure. All of this is automated, detected, and the information is sent directly into the hands of the mining engineers that need to see this and be able to respond to it in a rapid way. This improves their adherence to legislation, and in the most extreme case, we've actually seen production stops happening because of fall of ground that interrupted their operations, and we're able to detect this, much earlier on and enable them to operate better. So we turn our eyes a little bit to the continent, because I'm quite excited about some of the innovation that's going on there. And what we're seeing is that there's these ICT innovators and entrepreneurs that have started to plug themselves into the geospatial environment. And within this ecosystem, there's a whole range of very interesting solutions that are coming out. A friend of ours that operates a company called Located, based in Nairobi, has used geotagged photos to be able to enhance service delivery in a municipal area. He's able to look at the state of infrastructure, map out the way where water and where schools are. And from that information, they're able to then even analyze the distances that children have to travel from their homes to schools. How far is it that water reticulation has gone? And this has helped him to help his ward councillor, I suppose would be the best term, to improve the way that service delivery is enabled. And these guys in Mombasa are using mobile phones together with geospatial analysis to visualize the way waste is removed, in the city, and optimize that entire process. And lastly, some guys out of UCT were using a huge amount of satellite data to be able to detect what's called eutrophication. And it's these bacterial blooms in the water bodies. And he's done this over about 100 of the large water bodies in South Africa. And this operates in an automated process. And what's interesting now is that the time series of this is being made available, so you can start seeing deterioration of those water bodies early on and hopefully respond in a much quicker way. So I actually want to close on this note. I think that because we understand ICT in a developing world or in a resource-constrained environment, and taking those ideas and those thoughts and pairing it up with very interesting and innovative space technologies like nanosatellites. Now there's these guys out of Silicon Valley that are going to image the Earth every day at 3 meters. Now that's a huge amount of data that's going to be made available. But pairing that up together with guys that understand ICT in a resource-constrained environment, I think is going to enable the development of solutions that are highly applicable and localized, but more importantly, taken out into the rest of the world would be able to have much lasting impacts. Thanks.
Thanks, Lee. Thank you very much for that.